This tutorial walks through creating a flexible fluted glass material in Unreal Engine 5 using normal maps to simulate light distortion. Instead of modeling grooves directly into the glass, you'll use a normal map to refract light, producing realistic fluted, ribbed, or patterned glass with excellent performance. Before starting, under the Edit menu, open Editor Preferences and search for Substrate. Make sure to turn off the Substrate Materials options. The normal map is responsible for distorting the image seen through the glass. You can make your own normal maps or download them. Right-click in the content browser and create a new material, giving it a proper name. Double-click on it to open it in the material editor. The mesh itself affects the final result. If your window mesh has a real thickness, use the material normally. If your glass is a single polygon plane like my mesh, you need to enable the two-sided option in the Details panel of the material. Without it, the glass disappears when viewed from the back. Be aware that two-sided materials invert the normal map on the opposite side. Select the main material node. Change the blend mode to translucent. Under translucency, for the lighting mode, change this to surface translucency volume. This restores the following inputs: specular, roughness, metallic, and normal. Under the refraction section, change the refraction method to index of refraction, which gives you an input for refraction. Create a vector 3 by holding down the 3 key and left-clicking in the graph. Leave the color as default black and connect it to the base color. Add a scalar parameter by holding down the S key and left-clicking. Rename the parameter to specular and change the default value to 0.5. Connect the parameter to the specular input. Add a scalar parameter by holding down the S key and left-clicking. Rename the parameter to roughness and leave the default value at 0. Connect the parameter to the roughness input. Add a scalar parameter by holding down the S key and left-clicking. Rename the parameter to opacity and change the value to 0.3. Connect the parameter to the opacity input. Box select these nodes and use the C key to group them. Title the comment Base Glass. Drag one of your normal map textures into the material editor. Right-click on the node and convert it to a parameter named Normal Map. This allows different glass styles to use the same master material. Add a comment and rename it Normal Map. Connect the normal map to the normal input. To make the material reusable, expose tiling and rotation. Right-click and search for the texture coordinate node. Add a scalar parameter by holding down the S key and left-clicking. Rename the parameter to tiling and change the default value to 1. Hold down the M key and left-click to add a multiply node. Connect the texture coordinate and scalar nodes to the multiply node. Right-click and search for custom rotator. Connect the multiply node to the UV's input. Hold down the 1 key and left-click to add a constant vector node. Set the default value to 1. Connect it to the rotation center input. Add a scalar parameter by holding down the S key and left-clicking. Rename the parameter to rotation angle. Since the rotation angle of the custom rotator is limited to 0 to 1, hold down the D key and left-click to add a divide node. Connect the rotation angle to the A input of the divide node and change the B input to 360 to allow for 360 degrees. Connect this result into the rotation angle input. Select these nodes and add a comment and rename it UV. Connect the custom rotator to the UV input of the normal map. Now the texture can be rotated by simply entering degrees. Being able to control the strength of the grooves makes the material much more flexible. Add a scalar parameter by holding down the S key and left-clicking. Rename the parameter to normal intensity. Change the default value to 1. Hold down the M key and left-click to add a multiply node. Connect the red channel to the normal map of the A input of the multiply node. Connect the normal intensity to the B input of the multiply node. This will represent the x-axis. Use Ctrl-D to duplicate the multiply node. Connect the green channel of the normal map to the A input of the multiply node. Connect the normal intensity to the B input of the multiply node. This will represent the y-axis. Right-click and search for an append vector node. Connect the red channel multiply node to the A input. Connect the green channel multiply node to the B input. Use Ctrl-D to duplicate the append vector node. Connect the first append vector node to the A input. Connect the blue channel, which is the z-axis, to the B input. This will reassemble the channels and make sure everything is appearing correctly. Connect the second append vector node to the normal input. Select these nodes and add a comment and rename it to normal intensity. Apply and save the material. Back in the level, right-click on the material and create a material instance. Drag the material instance onto your glass static mesh. Double-click to open the material instance. Now you can change the parameters we set up earlier in the master material. When light travels from one medium to another, such as air into glass, it bends. This bending is called refraction. The amount of bending is controlled by the material's index of refraction, or IOR. To reproduce that behavior, use a Fresnel. Hold down the 1 key to add a constant vector and change the default value to 1. Hold down the S key to add a scalar parameter and rename it to IOR. Change the default value to 1.52. This is the standard IOR of glass. Right-click and search for the Fresnel node. Hold down the S key to add a scalar parameter and rename it to Fresnel falloff. Change the default value to 5 and connect it to the exponent input of the Fresnel node. Hold down the L key and left-click to add a lerp node. This will allow you to blend the Fresnel nodes. Connect the constant vector to the A input. Connect the IOR to the B input. Connect the Fresnel to the alpha input. Select these nodes and add a comment and rename it IOR. Connect the lerp node to the refraction input. Apply and save the material. If you open the material instance, you'll notice you have 2 more parameter values. Since the master material is driven entirely by the normal map, you can quickly create new styles by swapping textures. By combining a tiled normal map with physically based refraction and Fresnel blending, you can create a highly reusable fluted glass shader that can produce a wide variety of decorative glass effects. Exposing parameters such as tiling, rotation, normal intensity, IOR, opacity, and Fresnel falloff allows artists to create everything from subtle ribbed glazing to heavily distorted privacy glass using a single master material and lightweight normal textures. What will you like to learn next in Unreal Engine shaders? Let me know in the comments, and your suggestion might be the next tutorial.